Hello and welcome to another free code session. My name is Jason Bach, and before I started recording I actually had to turn off the computer to my right, which is a laptop that the client that I'm on, I'm a consultant, that's my day job, and so the client that I'm on, they want us to use their machines, not the one that I have right here. So, okay, fair enough. The original laptops that they gave us, definitely we're not going to cut it from a developer standpoint. They just did not have the horsepower underneath. So I got a new one shipped to me and went through with their IT help desk or something like that on Friday to get set up, which is pretty painless. Mostly just security, all their stuff that they need on their laptops, which is what it is. But I came in here this morning and it was like the fan was just, it was quiet, and as I sat down, all of a sudden the fan kicked in, and then it really kicked in, so I'm like, okay, just shut it down, what it was doing. But that was funny. All right, well, I thought last night that I was actually going to get pretty close to really building stuff, and I don't know if I'm there yet. What I forgot to realize is with something like again, okay, that is like, these are, you just don't call them. Like again, you just call and it returns that, but then you just do it. Okay. Defer actually determines, do you do all the rest of the things? Okay. So like here, defer says on line 3, if you don't defer, then you do this. If you don't defer, then you do this. So if you don't have a defer to start with, then you just simply do what's there. If you do have a defer in front of you, basically everything after the defer is dependent upon the return value of defer. And what you pass into again and defer matters. So for example, if you just see a number, then you actually have to call does line exist and return a boolean and do things like this. So I'm glad that I have greater than and less than already built in and greater than and equal to, because that's good. So now for something like this, a print, this is interesting because we have the ability, based on what I was following from Immel's compiler series, is this will actually produce an integer. So what we'd really need to do is something like this and say cast it. But as you notice, the code doesn't do that here. So it basically just assumes, well, if I have an int, then just convert it to string. You don't need to see the string in front of it. And honestly, I'm not quite sure how that actually, like, how did that string thing actually work in his stuff? So I may need to either take that out or modify it. So it's nothing too big here. Like, I can actually sit down and go, okay, I need to actually do this. I need to, handle these conditions, but I think I'm getting closer-ish. So before I do that, though, there's some other things I need to clean up. We're going to add a load file, but I'm not going to do that right now because, well, actually, no, I do need to do that right now. Okay, so let's go into the code. Excuse me. And sure, we need to go into the playground because I need to add another meta command that says if input is equal to load file, then what we need to do is load the file. And so what we need to say is this.lines.clear. Lines are just strings, right? Yeah, okay. So then what we need to say now is file.read all lines. And I could do it asynchronously. In fact, I really should to some degree, but that suddenly makes everything asynchronous above it, which is arguably the right thing to do. So I talked myself into it. So this is interesting because the input is not just load file. And I think he eventually addresses commands by allowing you to pass in more into the command. These are just simple commands, and we need to do something more to actually parse the command. It's never simple, is it? It's always more fun. All right, so let's actually do a little bit of pre-processing. So if the input starts with that, okay, then what we need to do is get file name is equal to input.split. Well, no, we want to do a substring because I don't know what's, so we want to say, and again, this is a little substring, we want to start at the index, so 1, 2, so basically the length. If, I think that's right. I think I got that right. If file exists for file name, then we will do this. Else, we want to print out something like this. No, back up. File name does not exist. Okay. And now we want to say this dot lines add range of file read all lines async. Okay, so we need to do an await here. What's the problem? Yes, async task, and here the fun begins. And then you come up here, and then this should be await, which makes this async, and then it's going to bark somewhere else, right? Oh yeah, it will bark now in the program because we're calling that, so we need to say, yeah. And then we need to say here, there, okay. So, wasn't too painful. All right, so we can load in a file and then actually do something with it, right? So if, well, I can't load any of those because they're gonna, they would blow up massively. So what we really want to do is load something like, let's do this. Simple one dot dub sharp. Actually, we're going to call it text because then it will get see if that actually completely boxes it. No, it doesn't. Okay, good. All right, so here we can do that. Okay. And we need to make sure that this is none, but we want to copy always. Okay. Then we take that and do that. And we say simple 2. Nope. Oh, I'm hitting the wrong key. There we go. And I hope that didn't screw anything up. And now symbol 2 does this. Okay. So if we run this, and I say load file quux.ws, it says invalid command. That's funny. That's hilarious. Why would it say? Because it. Oh, duh. That's why. Okay, so if you say load file quux.cs or ws, I feel like there's a space in there that it's getting that it shouldn't. Which is true. So what we want to do is say here, just trim it. You can deal with that. Load file. .ws. Okay, but now if we say load file simple1.ws, it loads. So now if I say run, hello, hello, hello. All right, so if we keep saying run here, yeah. So we sometimes get 2, we sometimes get 3. Okay, so now let's say load file simple2. And now if I say, let's actually turn the tree off, program turn that off. And now let's say run. So now if we say run, we always get 4. So there is a difference here. Okay, so that's actually pretty good. Let's actually commit that. Added a bunch of tests, which you have not seen me do, that I did off camera. Alright. Okay, so that's all good. And I think I'll keep them on for now. We'll see if that actually kind of annoys me to keep them on or off. Yeah. All right. So here's the problem. How do I determine what it is doing? Because it's obviously not the right thing. So, execution engine. So if I am correct, we here will say execute. Okay. Now the problem is here is that I have an action. I don't actually have code, so it's like what the action is actually doing is a little strange. So let's actually do this first. Let's go to the evaluator. Yeah. Because in the evaluator, we should have a call expression. Well, those are just calling those. Okay, unary line count, I need to look at that. Maybe that's what the problem is compared to an update line count, which is what that is. Okay, so let's run this in the debugger. Because if I remember right, both of these should do the same thing. They both just call update count. Okay, so let's do, you know what? No, let's leave those on for now. Load file simple1.ws. And simple1, if I remember right, that's the one that we're getting the right stuff. Okay, so we get a update line count expression. Of 1 and 2, right? So we should get a line of 1 and a count of 2. And the thing that's going to be different is the last line. Yeah, okay. And then we get line update of 1 and a count of -1. Yes, okay. So that's all good. And then it just runs. So now I'm going to say load file 2. run. Oh yeah, the first one has it. Okay. Sorry, it took me a second to realize what it was doing. All right, now here's the problem. So this should be 1, right? And the line to up. That's it. That was it. The line to update needs the absolute value, but the line number here needs to be the one to evaluate whether it's plus or minus. You can't absolute value that one. Okay. That was my mistake. Okay, so now we need this here, this here. But the line to update still gets the update count. There we go. Okay, so now if I do load file, simple2.ws, run, we get the exact same behavior, sometimes 2 and sometimes 3. Okay, so at least that's being consistent. That is now correct. Cool. So we fixed that one. Fixed a bug with using the absolute value of the line. Good enough. Okay. So that is off the list. We added that, so we're good. We got those done. Now let's go through some to-dos again. Okay. We did that, so that's good. Maybe I have an overload that doesn't take a value. Yes, I saw this yesterday, which is if your intent is to pass in a value, so this is actually being used in a fair amount of spots. So in some cases you don't have a value. In some cases you do. So what I'd like to do is actually say, hey, if you're actually calling this, then you should get an argument null exception. Make it a little bit more explicit. Even though it supports having a possible null value, if you are passing in, if you don't need a null value, then just don't pass anything in at all. That sounds, it's a minor thing, I think, but I think it will read a little clearer. Okay. See, in that case, it's okay because we do accept nulls. But in this case, what we're going to say is argument null exception. Name of value. Okay, so it just enforces that has to be that. Okay, so now let's go through all the code and find all the places that's being referenced. Okay, well, I just kind of shot myself in the foot. If the value is null, okay, so maybe this is a bad idea. Because I don't know. Okay, so I just answered my own question. We're going to take that out. But that's okay. That's what to do is. It's just to go consider. I should have a thing there go consider. This didn't have to be done. Just consider it. So I'm going to take this out. Okay, so that takes care of that one. This one, yes, the toString can get very heavy to see in a debugger. I'm kind of wondering if the toString here should actually return what I want from a diagnostic debugger attribute, because no one's calling toString on this anyway. Okay, so I'm thinking this is, to me, too much work for each node on a toString. So we're going to say return, what did I have up in the top here? I think that addresses the problem quite nicely. Okay? And so the point of this is, if I was in where would that be? In the parser. So if I'm in the parser and I'm going to, let's say I put a breakpoint right here, okay, and I run it, and now I say so now if I hover over line number, it's a literal expression 0 to 1. Okay. If I do lines, what I'm going to get is, well, lines, but I get the first one's an expression statement, 2 to 13. The expression is a calls expression 2 to 12. To me, otherwise you're getting that tree viewy looking thing in there, and that was just ugly as crap. So I think this is much better to read. And I'm out of coffee. All right. So I'm going to stop this. That is actually good. All right. So let's close this out. Look at my list. Should I enforce that the open and closed tokens are the right kinds? Yeah. Oh, this one this one is actually, it's working. Which is, if I have, where do I want to do this? I can just do this in Notepad. Okay, so if I have a program like this, 1, 2, add 1 to it. That's actually wrong, because you never had a line 2 in your program. Okay, so that will actually fail. But, so you at least, even if there's no instances of that line anymore, you still had to have created it. That's the way I'm interpreting it. Okay, and it actually makes sense, because if you try to just address anything, that it would be kind of useless. That'd probably be a bug. But if I did 2, 1, minus 1 here, that's okay, because both of those lines actually exist. Okay, so I think I'm going to keep this behavior for now. So that takes care of that one. Yes. So here's an interesting one. Is that the parenthesize expression syntax should always have an open parentheses token and a closed parentheses token. Okay. So what I'm getting at is, if I run this, okay, and I say 1, 2, 3 plus 4, and then I put a brace there, okay, and now I say run, you'll say bad character input that, okay, unexpected set token. So things are getting a little messed up here, okay. So what would happen if I said here, if open parentheses token kind does not equal syntax kind open parentheses token. Right now I'm just going to say throw no exception, because I don't know if I'm going to keep this. Okay. Or, whoops, nope. Or close parentheses token kind does not equal. Okay, so now if we run this, I say 1, 2, 3 plus 4, and now I say run. Well, I don't get an exception, because they were still considered. That's because I think we produce tokens, we say match. If we don't find it, we match, but we match with a token that we didn't get. If I remember right, from the parser, I think, match in parser, yeah. So we're reporting an unexpected token. We return the token anyway, but it's kind of like a bad token-ish type of thing. This is where the bad token, unexpected token, is coming into play. Yep. But we still, here, we'll say it is the right kind. That is the right position. We don't really know what the value should be, because it's bad, or It's bad, and then we return null. Okay, so this is the question though. Does it make sense to put this check in here? Would we ever really get this? This gets more to a design question of just good object-oriented principles, or just good coding principles in general. Do I trust myself enough that I would always be calling this with the right token? Or am I, do I trust myself enough, or do I write this the correct way such that I am checking for things coming in to be correct? I would say that what I probably should do here is say throw new. We don't have a parsing exception, do we? Do we have anything in here that's like a custom exception to say where this is coming from? No, I do not. What I could do is just put that in there, call that a parsing exception. No, do not do that. Is that a parser? Syntax. Okay, that's what I did. And then compiler. It's actually interesting. Oh, because it was up in that. Okay. Really? Yes. Okay, I was a moron. And if I knew how to do the right changes. Okay, there we go. So now we'll say parsing exception. We don't need to add a diagnostic. This is just horribly wrong. If you would try to pass in a token that's not an open parentheses token, what are you doing with my life? Should not happen. So incorrect. Kind is OPT kind. Okay, and we'll do the same thing for the closed parentheses token. And what are you doing? There. Okay. And then I can write a test for that, and then I'll stop this recording. I'm sure that there are other cases like this with other syntax and other things where I'm kind of debating whether I should do this or not. But to me, this is a really bad thing. Because the way that the parser is constructed is that it should always give you a token node of the right kind, but the parser is responsible for actually reporting that as a diagnostic and saying, hey, this is the problem, as you saw when it gave the error. Okay, so we should never actually be giving these tokens that they're completely the wrong kind of tokens. Okay, so I might have other. What are you barking at here? Oh, those need to be flipped around. So now if I have a parenthesized expression syntax, and I copy that, and I come to my compiler syntax, and I say, oh, I do have tests for this. Okay. This is probably where this came up, because I was like, what happens? You know? So if I say create with incorrect open parenthesis token. Okay, so here I'm going to say, I don't know, minus token. Because why not? Okay. And now what I should say is assert that doing that throws type of parsing exception. And that's it. And then the same thing goes for incorrect close parentheses token. So in this case, I didn't need to do that. Okay. But now we say here minus token. And yes, I could look at the exception and the message and say it should be telling me the right thing in both cases. Do I go that far? I'm not really sure. Yeah. I guess in the parsing exception, I could actually contain the thing that's failing, but like incorrect node expected or incorrect node given. For right now, I think this is sufficient. Okay, so we'll run all the tests and we'll see. You can do it. Come on, you just built it. What? Oh, for crying out loud. That actually has to be not running. And then come on. For crying out loud, really? How long does it take a test explorer to figure out all the tests? Oh, now you ran. Okay. Thank you. Thank you. And we're good. Okay, so we're going to commit this. And updated toString on syntax node and did check on C2 arguments. Ugh. I wish it had IntelliSense there. The size, the expression, Zandex. All right, so I'm going to do another one. I'm going to get some coffee, and I'm going to do another one, and try to start working on actually handling the method calls, because I got to do it eventually. So I might as well start diving in and figuring out how do we handle, and again, all these other ones, so we can hopefully start actually running what we really expect to run. So that's all the time I have for right now. Thank you all for watching. Leave comments and questions below. See you in the next episode.